Hello and welcome to the Logic Simulation Quick Tech video. This tutorial will primarily focus on running a simulation through the Vivado design environment. We'll walk you through the process of setting up the simulation, show how to launch Vivado Simulator, and then examine the results in the waveform viewer. The project creation process and managing sources are covered by other Quick Tech videos, so we will not cover that topic in this video and will directly start with the existing Vivado project. Let's start off by understanding a simulation set. A simulation set is a collection of simulation sources. In this example, sim_1 is the simulation set, which has a testbench file bft_tb, the design source bft, which is the top level file, and its instantiations. Now let's look at the simulation settings. The simulation settings are unique to a simulation set. In this example, we have only one simulation set, so all simulation setting changes will be applied to sim_1 only. If you have multiple simulation sets, then you can have unique simulation settings for each simulation set. The simulation settings has four options: compilation, simulation, netlist, and advanced. The compilation option is for parser and elaborator. In the case of Vivado Simulator, it's xelab command. The simulation option is for xsim command, and netlist is for the netlist writer and SDF generator, which is write Verilog, write VHDL, or write SDF. The Advanced Settings tab provides an option to disconnect design sources for simulation. If you look at the simulation set, the design sources are merely a logical mapping and not separate copies. All simulation sets by default will have logical mapping to design sources. So let's say you would like to simulate a specific module and not the entire design, then just uncheck this option and add the files to the simulation set. Since the testbench is providing stimulus to the top-level design file, we'll keep this option checked for this tutorial. Now that the simulation settings are done, let's look at running a simulation. When you click Run Simulation, you will see a menu with options to run behavioral, post-synthesis functional, post-synthesis timing, post-implementation functional, and post-implementation timing. If you notice, synthesis and implementation simulations are not active, and that's because there is no completed synthesis or implementation run. Once synthesis completes, then post-synthesis simulation will become active. Similarly for post-implementation. When I click Behavioral Simulation, Vivado automatically generates the project file and issues elaborated command, which is xelab for Vivado Simulator, followed by the simulation command xsim to bring up the simulator. Now that the simulation is up, let's look at the scope window. The scope window displays the instance and process hierarchy associated with the current simulation. You can filter scopes within the scope window using one of the following methods. To hide certain types of scope from display, click one or more scope filtering buttons. Or you can also click the zoom button and type the string in the text box to limit the display to scopes containing a specific string. Within the string, you can further filter by choosing to show the parent or child tree. As you can see, filtering out parent and child tree helps remove the information that you don't need and just shows the scope you're looking for. You can simply cancel the filter operation by clicking on the X, and you'll get all the instances and processes back. Now that we understand the scope window, let's look at the object window. The object window uses the same filter mechanism as you just saw in the scope window. The HDL objects window displays the HDL objects of the selected scope. So as you're selecting different scopes, you will see the object change. You can also right-click on any instance in the scope window and select Go to Source Code to bring up the source editor. The source editor will have arrows on lines that are executable code, which can take breakpoints. Simply clicking on the arrow will set up the breakpoint indicated by a red dot. You can also see the tickle command that was executed to set the breakpoint in the tickle console. If you want to clear the breakpoint, just simply click on the red dots and it will clear out the breakpoints. Now let's look at the waveform. The first thing to notice in the wave window is the zoom gestures. The zoom gestures are the same throughout the Vivado design suite, hence it reduces learning curve. You can move from simulator to device editor and use the same gestures for zoom. The waveform viewer supports analog waveform. In this example, sine is an analog signal. I can simply right-click on the signal and change the waveform style to analog. But since the radix is incorrect, you're not able to see the sine wave. So I'm going to change the radix to sine decimal, and now you will see the sine wave. The waveform viewer allows you to create a group of signals. You can select the signals you want to be in a group and right-click and choose New Group in the menu item, and then provide a name for the new group in the pop-up window. For example, I've grouped WB clock and BFD clock under the group called clock. Now that the clock group is created, you'll be able to see WB clock and BFD clock listed on the clock group tree. Similarly, you can combine signals to make a virtual bus by right-clicking on the signals you want to combine and choosing a new virtual bus. Here, I created a virtual bus of two 1-bit signal, reset and WB data for input, into a 2-bit bus called training. You can also add a signal divider by right-clicking on the signal below which you want to have a divider. The divider helps you separate a group of signals or bus. In this example, I'm placing a divider between the digital and analog signals. Enhancements to cursors and markers help you analyze the signals in the waveform viewer. You can use the menu option to move the cursor to time 0 or to the end of the simulation. You can also go through individual transitions by clicking on previous and next transition buttons. Marker can be easily added from the menu item as well, and you can measure the signal transition lengths easily. If you notice, the marker and cursor have hollow or filled circles while hovering over the signals. A filled-in circle indicates that you have locked over a transition of the waveform. This feature helps user eliminate measurement errors. You can also use the simulation menu options to restart the simulation, which resets an existing simulation time to 0. And you can also run the simulation for a specified time. In this case, I'm running the simulation for 1 microsecond. You can step through the HDL code for further debug by clicking on the step icon. If you want to run an open simulation to completion, click on the Run All button in the simulator menu. And you can interrupt the simulation by clicking on the break icon, which looks like a pause button. Finally, if you make any changes to the code, you can click on the relaunch button to recompile and relaunch the simulation. Once the simulation is done, you can exit the simulator by clicking on the X button in the blue menu bar on top of the waveform viewer. In summary, Vivado IDE provides an easier way to manage simulation sources and settings. It automatically sets up compile and simulation scripts and launches simulator. It has a fully integrated powerful simulator which is 3x faster than the IAC simulator. It also has a waveform viewer that is shared between simulator and logic analyzer, thereby reducing the learning curve. For more information on simulation, please refer Logic Simulation User Guide UG 900. Thank you.